Welcome to Skillzam, a cure platform, cross-skill, upskill, reskill, and expert skill. We are your best learning partner for life. Skillzam, keep learning. Welcome to the Skillzam section on components of a computer. In this section, you will learn about what does a computer contains. Building blocks of a computer. Every computer takes an input data, stores and processes it, and outputs results in some desired format. Input devices. Fortunately, computers have come a long way since 1970s, and we can now input data into them using a variety of easy-to-use devices. The most common input devices are the keyboard, mouse, and the touch screen. There are hundreds of other input devices like microphones to capture sound waves, scanners to capture image data, and a virtual reality devices to capture our body movements. Computers also receive input from their environment using sensors like motion sensors that detect changes in the movement. Other known input devices are digital stylus, USB guitar cable, push button, video camera, sensors like temperature sensors, moisture sensors, muscle sensors, flex sensors, motion sensors, etc. Output devices. Once the CPU is done processing the data, it often needs to output a result. A standard output device is a computer monitor which displays text, images, and user interface elements by lighting up thousands of pixels with different colors. A computer monitor with a calculator program displayed, like a calculator shows 3 plus 2 is equal to 5. There are many other ways a computer could output data. As long as an output device can interpret a stream of ones and zeros, it can turn the data into anything. Headphones output sounds, printers output ink on paper, projectors output light. Other well-known output devices are like 3D printers, laser cutters, LED, light-emitting diode, spotlight, audible alarm, signals for robots to perform acts. CPU, Central Processing Unit. A CPU is the brain of a computer containing all circuitry needed to process input, store data, and output results. CPU is constantly following instructions of a computer program that tell it which data to process and how to process it. Without a CPU, we cannot run programs on a computer. For example, a simple calculator program might instruct the CPU to take two numbers, 3 and 2, add them and send back the result 5. Thanks to the control unit that knows how to interpret program instructions and an arithmetic logical unit that knows how to add numbers. With the control unit and ALU combined, the CPU can process much more complex programs than a simple calculator. Inside the CPU, at a hardware level, a CPU is an integrated circuit, also known as chip. An integrated circuit integrates millions or billions of tiny electrical parts like transistors, resistors, capacitors, and others by arranging them into circuits and fitting them all into a compact box. We can visualize the layers of CPU chip. Some of those layers are physical devices like chip and transistors, and some of those layers are abstractions like logic circuits and gates. It's impressive that we can put together seemingly simple devices like logic gates to create CPUs that power complex devices like our phones, computers, and even self-driving cars. Components of a computer. The von Neumann architecture, also known as von Neumann model or Princeton architecture, is a computer architecture based on 1945 description by John von Neumann that describes a design architecture for an electronic digital computer with these components: input unit, control unit, arithmetic and logic unit, memory unit, auxiliary memory unit, output unit. The central processing unit, or a CPU, also called a central processor, main processor, or just processor, is an electronic circuitry that executes instructions comprising a computer program. A CPU performs basic arithmetic, logic, controlling, and input-output operations specified by the instructions in the program. This contrasts with external components such as main memory, I/O circuitry, and specialized processors such as graphic processing unit or GPUs. The control unit is a component of a computer's central processing unit that directs the operation of the processor. A CU or a control unit typically uses binary decoder to convert coded instruction into timing and control signals that directs the operation of other units like memory, arithmetic and logic unit, and input-output devices, etc. An arithmetic and logic unit or ALU is a combinational digital circuit that performs arithmetic and bitwise operation on integers, binary numbers. Combinational logic, also referred to as time-independent logic or combinatorial logic, is a type of digital logic which is implemented by Boolean circuits where the output is a pure function of the present input only. This is in contrast to sequential logic, which is nothing but the output depends not only on the present input but also on the history of the input. In other words, sequential logic has a memory while combinational logic does not. Main memory or primary storage, also known as internal memory or primary memory, often referred to simply as memory, is the only direct accessible to the CPU. The CPU continuously reads instructions stored there and executes them as required. Any data actively operated on is also stored there in uniform manner. This led to a modern random access memory, also called as RAM. Primary storage are also volatile. That is, they lose the information when not powered. Auxiliary memory or secondary memory, also known as external memory, differs from the primary storage in that it is not directly accessible by the CPU. The computer usually uses its input-output channels to access secondary storage and transfers the desired data to primary storage. Secondary storage is non-volatile, that is, retaining data when its power is shut off. Let us now consider this example. When a user enters the input from the input device like keyboard, the physical input is converted into binary information. In this case, a letter S is converted to a binary equivalent of 101011. How is this done? Like, a letter S has an ASCII code value of 83, which is then converted to the binary value of 101011. Starting from this binary number, the CPU calculates how to display the letter S pixel by pixel. The CPU requests the step-by-step instruction from the memory, which tells on how to draw the letter S. The CPU runs these instructions and stores the result as pixels in the memory. Finally, this pixel information is sent in the binary to the screen. The screen is the output device which converts the binary signal into tiny lights and colors that make up what you see. This happens so fast that it looks instantaneous. To display a single letter, a computer runs thousands of instructions starting from the moment your finger presses the keyboard. In this example, the output device is screen or monitor. There are many different types of output devices that take a binary signal from the computer and do something in the physical world. For example, a speaker will play the sound. A 3D printer will print an object. An output device also controls the physical motions like a robotic arm, a motor of a car, or a cutting tool of a milling machine. Typing a letter on the screen may look easy, but more complicated 3D graphics or a high-definition movie, modern computers often have multiple CPUs to process all that information and many terabytes of data to store it. No matter what you want to do with a computer, every single action is about inputting information from the physical world, storing and processing that information, and getting some output back to the physical world. In this section, you learned about different components of a computer and also how they interact with each other to produce the desired results. Thank you for learning with Skillzam and never stop learning.